Here is a residential building. It has a forced air system with two parts. The first is an air conditioning unit outside that supplies cool refrigerant to the main duct inlet in the basement of the house. The second is a furnace to which both the main supply and return ducts for the building are connected. These two main ducts are connected to smaller vents throughout the house, allowing for a uniform temperature everywhere in the building. Almost every new home constructed will have this type of heating and cooling system. The Therma Solaris system will be different in three ways. First, we completely eliminate the furnace and replace the air conditioning unit with a heat pump. A heat pump looks and works like an air conditioner, but can be reversed to produce heat as well. However, most heat pumps cannot work in very low temperatures, below minus 20 degrees Celsius or so. To make this work year-round, we bring the heat pump inside the basement in our control box and attach three sets of ducts to it. The first set of ducts connects the heat pump to the two main building ducts. The second set connects the heat pump to the environment, one inlet and one outlet. Finally, the third set of ducts connects the heat pump to our second product feature, a gravel reservoir. This 1.5 foot deep reservoir covers the entire footprint of the building and is installed during building construction. This thermal battery, if you will, can be charged using outside air. To explain how the system works, let's take the summertime as an example. At night, the system will circulate the cool air outside and cool the rocks in the storage container, expelling warmer air to the environment. Then during the day when it is hot outside, this cool energy is used by the heat pump instead of using the heat outside. Since the gravel temperature is closer to the required internal building temperature, the heat pump is much more efficient. In the winter, we pass the air through the third main component, solar air heaters. These simple panels, who are 3 to 4 times more efficient than solar PV panels, heat up the air before passing it through the gravel. For a full year, we estimate a reduction in energy consumption of approximately 80%.